Hello and welcome to another application video. I'm here at Minarik Drives again with Miodrag Zubic, Chief Design Engineer, and he has yet another application to show us. Miodrag, thanks again for being in another video.
No problem.
So what do you have to show us today?
This is a centrifuge. It is used in oil industry, and it uses brushless DC motor.
Brushless DC. So can we take a look inside this?
Well, what's in it is a lot of things. There's some relays, fuses, power supplies, and displays. However, what concerns us is the motor drive part, and this is the spot where Z1 Boss was or currently is, and we are now trying to use our new brushless design, and we also made sure that we make it mechanically compatible. This is a centrifuge, and the insides of it look like this. This is the turning part where they have these cups where the material is being placed. I mentioned earlier that this kind of load is unique because it takes very little force to be spinning this, so load is very low. However, the inertia, relatively speaking, is very, very high. This wheel takes a long time to stop by itself, and that presents a little challenge when it comes to speed control.
So what's the challenge from the customer here?
Well, in this application specifically, the technological challenge is the ratio between the load and the inertia that this motor sees. So for about 10 years, a Z1 Boss has been used in this application, and it performed successfully until the customer decided to change the motor. Since they changed the motor, there's serious oscillation that are happening, and we are trying to use the opportunity to put in one of our newer brushless drives.
So oscillations, you mean speed oscillations?
That's correct, yes.
Okay. And the job of a centrifuge is constant speed.
Constant speed, yeah. They want to spin this motor at 1800 RPM, plus minus 1 or 2. And currently what's happening is variations of plus minus 30 RPM. I'm going to demonstrate it for you now. Turn it on. Initial sequence. The speed is set at 1800 RPM, actually 1803. It takes somewhat a long time for it to speed up, but that's the previously mentioned inertia. And the speed will make a little bit of overshoot, however not a bad one at all, and it will settle at just about 1800 RPM. Compared to Z1 Boss, which is a single quadrant drive and has no ability to slow down this load, this drive has that capability, so if we say stop, the stopping happens relatively speaking quickly. So yeah, this is brushless application, tight speed control, velocity mode with a little challenge of the speed control and high inertia. However, from other videos, there may be noticed resemblance between the drives that we're using. This is actually a three-phase inverter platform that we developed in order to be able to run brushed DC motors, induction AC, three-phase or single-phase motors, or brushless motors, because all it really needs is a three-phase inverter and a logic board with a microcontroller.
That in itself is a whole other discussion about using the same platform for different motor technologies. But it is interesting to know that you can do AC, DC, or brushless with essentially the same hardware. So I want to thank you again for being in another video and explaining another interesting application.
You bet.
And thanks for watching.